Greetings to all our evaluators. We are from K4. We'll be presenting on our final year design project presentation for the production of nanocellulose from empty fruit bunch EFB. My teammates are Su Yen Yen, Isha Naili binti Muhammad Marizan, Fatih Nur Ain binti Masron, and myself Gagantia Organisan. Our supervisors are Prof. Madia Dr. Nurina Anwar, Dr. Priya Gemi, Adli Ismail from Petrofac, Nur Ain Muhammad Nafi from Petron Refining, and also Gunaraj Raman from McKinsey.
First is about the introduction of nanocellulose. So the physical and chemical property of nanocellulose is shown in the table. So the next is the uses of the nanocellulose. So we can see that the nanocellulose is most commonly used in the food, pharmaceutical, and medical industry. Besides, nanocellulose can be used as a thickener in the production of non-alcoholic hand sanitizer. The next is the world supply and the demand of the nanocellulose shown in the graph. Next is the chemical reaction involved in our process. So first one is a reaction in the pre-treatment reactor in which the lignin and hemicellulose dissolve in water to form the dissolved lignin and xylose. Second is the reaction in the acid hydrolysis reactor for nanocellulose production. The cellulose react with the water to form nanocellulose and glucose. Next is the economic analysis. So the total capital investment calculate is Rn 141.51 million per year, and the total product cost we calculate is 253.76 million per year. So next is the profitability analysis. The minimum acceptable rate of return MARR for our plant we set is 0.25. This is because our plant is still a new process. And from our calculation, we get the return of the investment is 0.31 per year, and the payback period is 2.15 years, which is less than the reference payback values, 2.91 years. So we can conclude our project is financially feasible, and the net return is Rn 4.77 million, and the net present value is Rn 64.27 million, and the net discount flow rate of return DCFRI is 0.79, greater than 0.25 MARR. So we conclude our project is financially feasible. Next is the break-even analysis. So from the general break-even curve, the breakpoint is 0.85 years, and the specific break curve, the breakpoint is 0.4 kilotons per year. And our design plant capacity is 6.5 kilotons. So this project is variable since the plant capacity is greater than the break-even point 0.4 kilotons per year. Next is the summary of the conception design. The detailed plot diagram of our plant is shown. So as we can see, we have involved 2 reactor units and 6 separator units, which are 2 centrifuge, 2 distillation column, 1 ultrafiltration, and 1 spray dryer. The detailed dimension and operating cost per year are summarized in the table shown. Next is about the graph of the economic potential FYDP2, FYDP3, and FYDP4. So the price of the raw material, catalyst, and the product are shown in the table. And from the FYDP2 curve, which indicates the blue color line, so at the conversion 0.8, we can see that the profit is not much increasing. So we can conclude this point is our maximum conversion.
Okay, for the process flow diagram, first of all, the EFB will go through dryer where we will remove all the moisture content in it, and then crusher, and then go to the shredder where all the EFB will form into the fiber form and go through the pre-treatment reactor for the dissolve of lignin and also hemicellulose. And after that, we will go to a centrifuge where all the dissolved lignin and xylose will enter the distillation column, and the cellulose will enter the main reactor at 110 degrees Celsius at 7 bar. And then the first separation part after the main reactor, which is a centrifuge, will separate the nanocellulose and also glucose, and the remaining cellulose form will recycle back into the main reactor. And at the ultrafiltration, where the filtration technology have a pore size that basically will allow the impurities to pass through the while retaining our product, which is nanocellulose. And then the nanocellulose will go to a spray dryer, will form into the powdery form, and then the steam at 220 degrees Celsius also will enter the spray dryer, and then all the nanocellulose will enter the storage tank. And for the distillation column above, where the glucose purity at 96%, we will sell it to the other company.
Next, for the process control, in our process we have 6 control parameter, which is temperature, pH, pressure, level, composition, and flow. They are the example of our process control, which is R100 and R101. Next is pressure relief valve. In our process, we have 2 pressure relief valve, which is located at reactor R100 and reactor R101. Next is piping and instrumentation diagram. This is our full of process control in our process.
Okay, for process safety, we will use all these 3 regulations. For hazard system, we have 5 hazard systems that we apply in our plant, which is chemical, biological, mechanical hazard, and also electrical and electromagnetic hazard. For hazard system, we have 3 chemical that hazardous in our plant, where the very hazardous chemical is hydrochloric acid and also acetone. For the receptor, operator on duty, and also the residential that live nearby in our plant. For the barrier non-physical, we need to have emergency response plan. Also provide training for our operator, and also regular inspection and maintenance for all the unit plants that involve hydrochloric acid. The hierarchy of our plant, for the spray dryer, we have a high temperature of the steam, which is we can cause a heat release to the surrounding. We need to wear a protective and isolate a safeguard area for workers to enter.
So the industrial location is an important thing to determine the patterns of the manufacturing. So we have classified our locations, which is Kantan Industrial Park Perak, Kapal Industrial Park Kapal Kelang Selangor, and also the Jalan Bandar Gambang 1, Kampung Pulau Manis, Pahang, into those criterias, and we evaluate these locations accordingly. So for the weightage for the evaluation of location criteria for plant, we rank up the scale specification for the criteria. For example, for the power supply, incomplete electric power supply will get the score from 0 to 3. Medium electric power supply will get the score from 4 to 7, and also the complete electric power supply will get the score from 8 to 10. With that order, our Kapal Industrial Park Kapal Kelang Selangor hold the highest ranking with the score of 102. So Kapal Industrial Park Kapal Kelang Selangor chosen as our plant location. The pictures are attached as a proof of the location. And also for the plant layout, the cost, operation, safety, plant expansions, space utilization, and also the general consideration had been considered. And when designing the plant layout, we have considered the wind direction. We also had the sufficient parking, washrooms, prayer room, canteen, and also administration office, and assembly area also included.
Next is waste management. In our process, we have 3 waste minimization, such as recycle, stream added, treatment, increase the retention time. Okay, next is concentration of COD, BOD, and suspended solid. Before we calculate, we must assume first density of wastewater is 937.5 kilogram meter per cube. Next is BOD value is 0.3 COD. After that, we calculate for the table, also show the comparison between the value before the wastewater treatment and value of the standard B. This is value of wastewater treatment. First process is equalization tank. The product went to the aeration tank. After that, it went to the clarifier, which is to separate the liquid solid phase. Some of the product will recycle to the aeration tank, and some went to the chemical precipitation tank. Then it will go to the clarifier. Some of the product will enter the sludge tank, and some of the product will enter to the chlorination tank. For the sludge and clarifier, we enter to the sludge tank, and then we will dispose.
For the conclusion, our process is to produce nanocellulose where the EFB is our raw material. It will undergo 2 processes such as pre-treatment and also the hydrolysis process. Yeah. The energy recovery percentage is 33.49% for overall production process. In economic analysis, the value of return of investment is 31.21%, which is larger than MARR, and the value of payback period is 2.15 years, which is lower than the payback period reference. Thus, this project is profitable and also considerable. That's all from us. Thank you.